In this video, we want to consider the meaning of the coefficients of the lines we had plotted in the last video. So if we recall, the line on the left was y equals 2x minus 3. The line on the right is y equals negative 2/3 x plus 4. They're both in the form of y equals a value times x plus a value. We call that, mathematicians would say that's in the form of y equals mx plus b, which they call the slope-intercept form. We'll see why that's the case in just a minute. Okay, so let's first of all consider why the second number is b is related to the intercept. So to do that, what we'll do is consider what happens when x equals 0 in each case. When x equals 0 in the first case, y is equal to 2 times 0 minus 3. The first term goes to 0, so we are left with y is negative 3. That's exactly where this function crosses the y-axis. Okay? So this is called the y-intercept. So the y-intercept corresponds to the value negative 3 in this case, because that's all that's left when x equals 0. In fact, another name for the y-axis is x equals 0, because the x value is always 0 on the y-axis. Let's apply the same logic to the second case. Y would be negative 2/3 times 0 plus 4. So when x is 0, we are left with, this term will go away, and we are left looking at y equals 4, which exactly corresponds to where this crossed the y-axis, or the y-intercept. And once again, that's where x is 0, and so the y value will in fact be 4. Now, you'll notice in the generic form, the general form of the equation, y equals mx plus b, it's always plus b. So in this case, on the left, we would say that b is negative 3. So we can think of it as adding negative 3. Whereas the case on the right, we would say b is equal to 4. So when we have an equation in this form, we can immediately see where it's going to cross the y-axis. Now let me erase what I have down below, and then we will come back and look at the first coefficient. So in the case of the equation on the left, its first coefficient is 2. So let's try to see what that means. So what does that mean? Okay, so when x is 0, we already have established that the y value has to be negative 3. When x is 1, we come over 1 unit, and we can see if we move up here, we would see this on our table as well, the y value has gone up by 3. So when the x value went up 1, the y value went up 2 because of the coefficient 2. When x equals 1, we're going to add 2 to the original value at the y-axis. When y goes up another 1, it is now going up a total of 2. So the x value has gone up by a total of 4. But we go over 1 and up 2, and we go over 1 and up 2 again. So you'll see that no matter how far we go, the amount we go over and the amount we go up is in a 2-to-1 ratio. So 2 over 1 is the amount that y changes over the amount that x changes. It's a 2-to-1 ratio. So when x changed by 1, y changed by 2. If x changes by 2, y changes by 4, and so on. If we go in the opposite direction, if x were to change by negative 1, that would mean that the y value would have to change by negative 2. It's still a 2-to-1 ratio, negative 2 to 1. And also if we had fractions involved, if x had changed by 1/2, y would only change by 1, but that's still a 2-to-1 ratio if we were to look at all of those things. So the m value is the rate at which y is changing with respect to x changing, and that is called the slope of the line. Let's come over to the other equation. This one has a slope that is apparently negative 2/3. Let's see what that means on this graph. Since we started at a value of 4, every time x goes over by 3, it's a 2 to 3 ratio. So let's see what happens when x goes over 3 plus 3, y goes down minus 2. And when x goes over another 3, y goes down another 2. So we have a perfect 2 to 3 ratio. Actually, it's a negative 2 to 3 ratio for the change in y to the change in x, which we could call negative 2/3. So once again, that is the slope of the second graph. We don't have to change the x value by 3 units. What this would imply is if the x value went up 1 unit, then the y value would go up by, or would it go down, I'm sorry, by exactly 2/3 of a unit. So if we consider this triangle right here, when x went up by 1, y didn't go down by 1, it only went down by 2/3. X has to increase by 3 to make y go down 2. So we still have the same ratio. And if we go backwards, if x had gone down by 3, then y would end up going up by 2. But it's always a negative 2 to 3 ratio. In this last example, it was a 2 to negative 3 ratio, but mathematically that is equivalent.